Look up on a clear, dark night, and you might spot a faint, elongated smudge of light. That quiet, seemingly unchanging blur is the Andromeda Galaxy. We live inside a galaxy, the Milky Way, but being trapped inside its flat disk means we cannot step back to see its shape, its overarching structure, or how it ages over time. We are essentially blind to our own home. That is what makes Andromeda so valuable. Sitting 2.5 million light-years away, this massive spiral galaxy is a near-perfect twin to our own. It's close enough to study in incredible detail, yet far enough away that we can observe its entire disk at once. For decades, astronomers assumed this twin was in the prime of its life, but ultra-high-resolution data reveals a very different reality. Andromeda is quietly stepping into its twilight years. Decoding how and why Andromeda is suddenly aging gives us a detailed biography of a neighboring galaxy. More importantly, it offers a direct preview of the ultimate fate awaiting the Milky Way. To see this aging process, astronomers turn to the Hubble Space Telescope. Orbiting high above Earth's atmosphere, it provides a razor-sharp view of the cosmos. Over the course of a decade, two massive observation programs stitched together more than 7,300 individual Hubble exposures. The result is a single 1.5 billion pixel mosaic spanning a massive stretch of Andromeda's disk. The sheer scale of this data is hard to overstate. The telescope was powerful enough to resolve 200 million individual stars across the galaxy. It is the equivalent of photographing a beach from miles away and distinguishing individual grains of sand. Each star acts as a tiny fossil, letting researchers reconstruct a detailed history of the galaxy's stellar birth cycles. The methodology relies on a simple rule of stellar physics. Massive, bright blue stars burn incredibly hot and die young, meaning any blue star we see formed recently. Conversely, smaller, redder stars burn their fuel slowly and can live for billions of years. Researchers divided the Hubble images into thousands of smaller squares, measuring 300 light-years across. By calculating the exact ratio of young blue stars to old red stars in every single parcel, they could read the galaxy's entire history backward in time. This chart shows the rate of star formation in Andromeda over the past 500 million years. The data reveals a stark, continuous decline in the galaxy's ability to forge new stars. 500 million years ago, Andromeda was building stars at a healthy pace, but today that production has plummeted to 1/5 of a solar mass per year. This steady decline accelerated into a collapse 40 million years ago, dropping off a cliff. To figure out why the stellar assembly line shut down, astronomers isolated two culprits. The first is a massive ring of gas and dust that circles the galaxy about 32,000 light-years from its center. For millions of years, this specific ring was a hyperactive nursery, responsible for 60% of all starbirth in Andromeda. As the material in that ring naturally depleted and faded, it dragged the galaxy's overall production rate down with it. The second culprit is much more violent. A cosmic hit-and-run orchestrated by one of Andromeda's own satellite galaxies, a dense star cluster known as M32. Roughly 60 million years ago, this satellite galaxy plunged straight through Andromeda's rotating disk. The gravitational shockwave rippled outward, severely disrupting Andromeda's delicate internal structure. The collision scattered the dense clouds of interstellar dust required to forge new suns. In the wake of M32's path, it left behind a massive dead zone, a region completely devoid of recent starbirth. Between the exhaustion of its main stellar nurseries and the violent disruption of a galactic collision, Andromeda has been pushed out of its active prime and into a quiet, quiescent middle age. Back here at home, the Milky Way is still comfortably churning out about 1 solar mass worth of new stars every year, but our supply of interstellar gas is finite too. Andromeda's quiet transition is a direct preview of our own galaxy's future as our fuel inevitably runs out. And our futures are tied together in a much more literal sense. Despite being 2.5 million light-years apart, the Milky Way and Andromeda are locked in a gravitational embrace, rushing towards each other at 110 kilometers per second. In about 4 billion years, these two sprawling spirals will collide. the interaction will warp their structures entirely, eventually merging them into a single, massive, featureless oval, known as an elliptical galaxy, a combined home astronomers have already named Milkdromeda. So, step outside on a clear night and find that faint smudge of light. You are looking at a cosmic mirror. It reflects the quiet aging process occurring in our present and serves as a window into the inevitable convergence awaiting us at the end of our galaxy's life.